Hi everyone, in this video I am going to discuss first question of September LeetCode challenge. So we are given an array of 4 digits and we have to find the largest 24-hour time that can be made. We know that the smallest 24-hour time is 00:00 and the largest 24-hour time possible is 23:59. Okay, so we are given an array of 4 digits and we have to find the maximum or largest time possible from these digits. There could be multiple time possible, but we have to make the largest time and return it. If it is not possible to make the time from the given digits, then we just have to return empty string. Now I'm going to show you how we can solve this. Okay, so the first idea is to find the constraints for each position. I'm going to use the same example given in the question 1 2 3 4. So we all know that we can fill in the first position by any digit from 0 to 2. We cannot fill in 3, it is invalid time. Okay, or any number greater than 3 or greater than 2. In the second position we can fill in digits, but it depends upon the digit at the first position. If the digit at first position is 0, then we can fill any digits from 0 to 9 at this second position. If the digit at first position is 1, then we can again fill the second position by any digit from 0 to 9. And if the digit at first position is 2, then we can only fill the second position by digits from 0 to 3. So 4 is also invalid. So any digit greater than 4 greater than 3 is invalid if the first position is 2. Okay, now the third position we can fill by any digits from 0 to 5. Any digit greater than 5 will be invalid for this third position. There is no time with 6 at this position. Finally, the fourth position we can fill by any digit from 0 to 9. Okay, so these are all the constraints for each position. Now let's move to the second part of the question. We have to maximize the time. Okay, it is not enough to find the valid time, we have to find the maximum time. So what we can do is we can try to fill this first position by 2 first and try to build a valid time. If it is possible, then we will return that as our answer. But if it is not possible to build a time with 2 as the 0th position, then we will try to see if we can build a valid time with 1 at this position. Okay, so we will start with 2 and then we will go to 0. Okay, again for the second position, if the first digit is 0, then we will try to fill this position first by 9, then 8, then 7, then 6 till we reach 0. Okay, if it is 1, again we will do the same. If it is 0, then we will try to fill this position by first 3, then 2, then 1, then 0. And we can use recursion for doing this. We will move to the third position. Again we will start off with 5, since we have to maximize our time. Then we will try to fill 4 at this position and then 0. Again for the fourth position also we will do the same. We will start with the maximum value, then the second maximum, and then till we reach 0. Okay, so this is how we can solve this, and I will show you how by running this on this 1 2 3 4 example. So the first thing we need to do is we need to find the count of each digit, and we can store it in our digit counts array. So the index represents the digit count. So initially we can assume that all are storing 0 count, okay, all digits. Then we'll increment 1 by count 1 because 1 is present here. Then we'll do the same, we will increment the count of 2 by 1, then we will increment the count of 3 by 1, and also we will increase the count of 4 by 1. All remaining digits have count 0, okay. Now we will try to run this example in our algorithm. So we will first try to see whether we have 2 or not. We have 2 in our digit counts, so we will decrement it and we will store 2 here, okay. Now we'll move on to the next position. We can fill this position by any number from 3 to 0. We will see whether we have 3 or not. We have 3, so we will decrement the count of 3 and we will store 3 here. Then we will move on to the next position, third position. We can fill this position by any digit from 5 to 0. We will check whether we have 5 or not. We don't have 5. Then we will check 4, whether we have 4 or not. We have 4, so we will decrement 4 and we will store 4 here. Then now we will move on to the next position. Next position we can fill in by any digit from 9 to 0. So we will check whether we have 9 or not. We don't have 9. Then we will check 8. We don't have 8, and we will keep on doing this until we reach 0. But before reaching 0, we will see 1. So we can see that we have 1, so we will store 1 and decrement the count of 1. So 2 3 colon 4 1 is our maximum time possible using this 1 2 3 4 array, okay. Now I will show you how to run the same approach on this example 2066. It is a bit tricky, okay. So again we have 4 positions to fill. We will start off with 2, but before doing this, let's update our digit count array also, okay. So we have 1 0, so we will increment the count of 0 by 1. We have 1 2, we will increment the count of 2 by 1. We have 2 6, so we will increment the count of 6 by 2, and the rest will be 0. Now let's move here. So the first position we will try to maximize it, so we will try to store 2 here. So 2 is present, we will decrement the count of 2 and store 2 here. Now next position, we'll try to maximize the next position. Since it is 2 in this position, so we can fill the digits 3 to 0 at this index, at this position. So we will check whether we have 3 or not. We don't have 3. Then we will check whether we have 2 or not. We don't have 2. Then we will check whether we have 1 or not. We don't have 1. Then we will check whether we have 0 or not. We have 0. So we will decrement the count of 0 and put 0 here at the second position. Now we will move on to the third position. Third position, we saw that we can fill it from 5 to 0, okay, but the remaining digits are 6 2 6, okay. So there is no element with 5, so we will just iterate through 5 to 0 and we will not see any number, okay. So it means that we have to recurse back from here, okay. We cannot move forward. There is no digit which we can fill at this third position, so we will recurse back. We will reach 0. So we have seen 3 2 1, so we will recurse back again to this position, okay. So but while recursing back, since we have not used 0, we will again increment the count of 0 by 1 and the count of 2 by 1. We have to recurse back here. Now the next big number which we can store at the first position is 1. we will check whether we have 1 in this array or not. We don't have 1, so the next big number we can store at this position is 0. We will check in our digit counts array whether we have 0 or not. We have 0, so we will decrement the count of 0 and store 0 here. Okay, now the constraint of this second position changes. Since we have 0 at the first position, we can store any number from 9 to 0. Okay, we will try to put 9 at this second position because we have to maximize it, but we don't have 9. So okay, so we'll just keep on looping from 9 to 0. Okay, so we will stop at 6 because we have 2 6. Okay, so we will decrement the count of 6 by 1 and we will store 6 here. Now we will recurse and we will move to the next position 5. We can fill any digit from 5 to 0. Okay, so we will again iterate from 5 to 0 and we will see whether we have any digit. When we reach 2, we will decrement the count of 2 by 1 and we will store 2 here. Now we will move to the last position. We know that the constraint for last position is any digit from 0 to 9. Then we will start with 9 again, and then we will check 8. 8 is also not present. We will do this until we reach the 6th position. So count of 6 is greater than 0, so we will decrement it and store 6 here. So the maximum time which is possible using this array is 0 6 colon 2 6. So this is my approach. Now let's look at the code. So I have implemented it using Java. So I have defined one class largest time for given digits. Okay, and then I have defined one main method, and this is the method largest time for digits, where we have passed one given array as an argument. Here I am initializing my digits count array to 0 values, and then here I am just storing the count of each digit in my given array into my digits count array. Here I am just initializing one deq. I am using deq as a queue in this, and now I am just invoking build largest time for digits method, and I am passing array digit count and array deq as argument. Okay, it will return array deq, and from that array deq I will just build the time. Okay, and I will just return the string representation of this string builder. So let's see what's present in this build largest time for digits. So here I am just doing the same thing which I explained over here. I am first trying, if the size of the array deq is 0, then it means that we are trying to fill in the first position. Okay, so we can fill the first position from 2 to 0 digits. Okay, we can fill either 2, 1 or 0. So this is one helper method which I have defined. Here I am just iterating from the end to 0 value and trying to store that value in my array deq structure. Okay, and here I am just calling this method again. So I'm just moving ahead, trying to find the maximum time by storing the first position. Okay, so if we have not find any digit, as in this case we didn't find any digit which we can fit in at the third position, so I'm just popping that digit and incrementing the count of the digit counts array, and I'm just returning back the array deq. So we are basically backtracking. Okay, so here is the main logic in this method. If the size of array dq is 0, so it means that we are trying to fill in the 0th position. If the size of array dq is first, and it means that we are trying to fill in the second position. If the size of array dq is 2, then it means that we are trying to fit in the third position. And if the size of array dq is 3, that means that we are trying to fit in the fourth position. Fourth position, we can fill the maximum value 9, and we can fill in any digit from 9 to 0. For the third position, we can fit in any digit from 5 to 0. And for the second digit, it depends upon the first digit, so that's why I'm checking the first digit. If it is 2, we can fit in any digit from 3 to 0 at the second position. Otherwise, if the first digit is 0 or 1, we can fit in any digit from 9 to 0. Okay, so let's run our program on these examples. Okay, so this I showed you by running here. So 23:41 is the maximum time which is possible. For the second example, I also showed you here 06:26 is the maximum time which is possible, and similarly for the other times also it has printed the maximum time possible. So that's all for this video, guys. Thank you for watching this video. Bye.